Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. Please, as you are watching this video tonight, endeavor to subscribe, like, share, and comment. Now, before I get started, I want to say a very big thank you to my subscribers who have been encouraging me in this teaching job. Please, I really appreciate your subscription, okay? So please also try to forward the link to your friends so that they can also subscribe to my YouTube channel. I really appreciate that. Thank you very much. So tonight we shall be discussing Physics 111, a topic heats energy, okay? In this topic, we are going to be tackling different terms that tend to be confusing, like heat capacity, specific heat capacity, latent heat of fusion, latent heat of vaporization, okay? Now the first one is what? Latent latent heat of fusion, okay? The first one is, excuse me, let me get a better marker. No, sorry about that. Now the first one is heat capacity. Now heat capacity means the quantity of heat required, needed, or supplied. Heat capacity can be defined as the quantity of heat needed or supplied or required to raise the temperature of the mass of a substance by 1 Kelvin. All right, it is the temperature needed or required or supplied to raise the temperature of a body, to raise the temperature of the mass of a substance, of an object, by 1 Kelvin. And it is given as Q equals what? MC change what? Temperature. All right, this temperature could be Q2 minus what? Q1, that is changing temperature. Now, Q connotes what? Quantity of heat. Quantity of heat. All right. Then M connotes the mass of the substance. Oh God, mass of substance. Then you now have C. C here connotes specific heat capacity. All right. Please, I said heat capacity means what? The quantity of heat needed or required or supplied to raise the temperature of the mass of a substance by 1 Kelvin. Okay, you now have what? Specific heat capacity. Now the difference between this very one and this one is what? Units. So I would say that specific heat capacity means the quantity of heat required or needed or supplied to raise the temperature of a unit mass of a substance by 1 Kelvin. So the difference between heat capacity and specific heat capacity is what? Units. I said specific heat capacity can be defined as a quantity of heat required or needed or supplied to raise the temperature of a unit mass of a substance by 1 Kelvin, by 1 what? Kelvin. And it is denoted as what? Small letter what? C. On all of these, they are what? Scalar quantities. Now, how do we know the SI unit of SH and C? It is very simple. It is a Q, it is C, all right? C is equals Q over what? M change what? Temperature, all right? Quantity is usually in joules. Quantity is in joules. Then mass is in what? Kilogram. And of course, temperature is measured in what? Kelvin. If these two idiots go up, it becomes joule per kilogram, then per what? Kelvin. Alright, so this is the SI unit of what? Specific heat capacity. I said the difference between heat capacity and specific heat capacity is the units. Alright, the heat, the what's it called now? The heat supplied or needed or required to raise a unit mass of a substance by 1 Kelvin is called what? Specific heat capacity. But the heat required or supplied or needed to raise the temperature of a substance by 1 Kelvin is what? Heat capacity. Take note of that. So this is specific capacity and this is what? Heat capacity. It is very, very important. Now that is for that. And before I go into latent heat, before I go into latent heat of fusion and latent heat of vaporization, let me quickly say something. The process of reducing the amount of heat excuse me, the process of reducing the amount of heat lost to the environment is called what? Lagging. All right, lagging is a process in which heat lost is reduced to the environment. That is, the amount of heat lost to the environment is reduced through a process called what? Lagging. Okay, now please, the amount of heat lost by a body is called what? Calorimetry. Calorimetry. Right, that is the measure of the heat lost by a substance is called what? Calorimetry. And calorimetry is under the influence of what? Calorimeter. All right, calorimeter is used to measure the amount of heat lost, all right, by a substance. Now there are different types of calorimeters. We have the glass calorimeters. We have the glass calorimeter, right? And we then have the Regnat calorimeter, all right? We have the ice calorimeter, and we have the bomb calorimeter. So calorimeter is used to measure the amount of heat lost. Then the process of measuring this amount of heat lost is called what? Calorimetry, and it's measured is what? Calorimeter. These are the various types of calorimeter. We have the glass calorimeter, Regnat calorimeter, ice calorimeter, and what? Bomb calorimeter. Please take note, heat of combustion is measured is what? The bomb calorimeter. The heat of combustion is measured using the bomb calorimeter. It is very, very important. So that is for that. Okay, the next one we are going to be taking is okay, let us take latent heat. We've established heat capacity, and we have also established specific heat capacity. Now the next one is what? Latent heat. Please, there's something you have to take note of in latent heat. There's what we call constant temperature and pressure. All right, these two terms are very, very important. When you are stating the meaning of latent heat, you must include at constant temperature and what? Pressure. Now let's go, let's jump into it. What is latent heat? Latent heat means the quantity of heat needed or required to change, that is to change the mass of a substance at constant temperature and what? Pressure. The amount of heat required, all right, to change the mass of a substance at constant temperature and pressure is called what? Latent heat, right? The amount of heat required, all right, for ice to become liquid, for ice to melt to become liquid, you call that what? Specific latent heat of fusion. All right, specific latent heat of fusion means the quantity of heat required or needed to, that is to change the mass of a solid, to change the mass of a solid, all right, in it what? Melting point to what? Liquid. All right, latent heat is just the quantity of heat required, all right, to change to change the mass of a substance, all right, the body of a substance, okay, at constant temperature and what? Pressure. Now we have two types of latent heat. We have specific latent heat of fusion, and this one has to do with what? Ice. All right, we now have what? Latent heat of what? Vaporization. This one has to do with what? Liquid becoming what? A gas. So the temperature of the quantity of temperature required or needed to change the mass of solid, which is ice, all right, in its melting point to what? To become liquid, is called what? Latent heat of fusion. Okay, it changes from solid to what? Liquid. Latent heat of fusion, and it is given as MV, all right, latent heat of fusion, that is, sorry, fusion, okay, MF, all right. Now Specific latent of fusion now becomes, okay, it becomes Q equals what? MLF. All right, MLF. M is the mass, then LF means what? Latent heat of what? Fusion. That is for that. But the heat required or needed or supplied to change the mass of a substance, which is the liquid, in its boiling point to become what? A gas, is called what? Latent, specific latent heat of what? Vaporization. All right, specific latent heat of fusion is to solid becoming what? Liquid. All right, then specific latent heat of vaporization is liquid becoming what? Gas. The temperature required or needed to change the unit mass, please, unit mass must be set in latent heat of fusion and in specific latent of fusion and specific latent heat of vaporization. That is unit mass. It is very important. Okay. Okay. All of these are scalar quantities. The quantity of heat required or needed, all right, to change the unit mass of a solid in its melting point to liquid at constant temperature and pressure is called what? Specific latent heat of fusion. Right? Then the quantity of heat required or needed or supplied to change the unit mass of a liquid in its boiling point to become gas is called what? Specific latent heat of what? Vaporization. Gas, liquid vaporizes. That is, if liquid is subjected other temperature during boiling, it boils, right? Once it's boiling, it becomes what? Gas. Once this gas becomes liquid, that becomes what? Condensation. All right, that becomes condensation. I said lagging is a process of what? Reducing heat loss to the surrounding or what? The environment. I said the process of measuring the amount of heat lost from a substance is called what? Calorimetry, and it's measured using an instrument called what? Calorimeter. All right, and there are 4 types of calorimeters. We have the bomb calorimeters, which is used to measure heat of combustion, and we have the Regnat calorimeter, we have the glass calorimeter, and we have the ice calorimeter. Please take note of that. Now, in this topic, now I've given you the meaning of every term. All right, so in this topic, we are going to be treating a lot of calculations. Now, please, the relationship between, let me say, water, right? Relationship between water, ice. Whenever you hear the word ice, what will come to your mind? Specific latent heat of what? Fusion. Whenever you hear the word of, okay, you have calorimeter, and you have what? Copper. The relationship between water, ice, calorimeter, and copper is very, very easy. To express this, all right, to look for the quantity of this idiot, it becomes Q equals the mass of water times the specific heat capacity of water, then times what? Temperature change. Okay, temperature what? Change. That's Q. Then plus the mass of ice times LF. That is specific latent heat of what? Fusion. Then times temperature what? Times temperature what? Change. Alright? Then plus the mass of calorimeter, specific capacity of calorimeter, and temperature change of what? Calorimeter. Then plus the mass of copper, all right, specific capacity of copper, then plus temperature what? Change. That is what you have it to be. Okay, now in this topic, there's what we call equilibrium temperature or final temperature, what? Or stable temperature. Final, equilibrium, stable, they have the same meaning. If a person wishes to bathe with hot water or with warm water, at first, as soon as the water boils, the person will have to like add more water so that the water becomes what? Warm. That is where you now have the law of calorimetry, which states that heat lost by a substance, the heat lost by a substance by a hot substance, to be specific, is equals to the heat loss, the heat gained by the cold substance. All right. So please, the law of calorimetry states that the heat lost by a hot water is always equals to the heat gained by the cold water. So which means that as soon as more water is added to the hot water, it becomes warm. All right. That warm water is called what? The equilibrium temperature, or the temperature that warm water possesses is called what? Equilibrium temperature, or final temperature, or what? Stable temperature. That is for that. To fully express this, to fully express what I have here, I'm going to be using, listen, always take note something. T3 minus T1 is equals what? T2 minus what? T3. Now this T3 is what? The final temperature. T1 is the initial temperature, and T2 is change the temperature, and this and that what? Final temperature. Whenever I see T3, always note is what? Final temperature, or equilibrium temperature, or what? Stable temperature. So which means that in place of this place, I can put Q3 minus Q1, then plus Q2 minus what? Q3. So please take note of this formula. It is very, very important. Now, apart from what I've just deduced, what I just did is called mixing method. Mixing method, okay? We also have what is called electrical method. Electrical method. How do we deduce the formula? Now, electrical method, you know that from electricity, Q, that is, you have Q equals what? MC change what? Temperature. All right, from electricity. Who is recording? Excuse me. Yes, it is. Now, from electricity, you agree with me that Q is equals what? IT. That becomes what? MC change what? Temperature, equation what? 1. All right. IT is equals what? MC change the temperature, that is equation 1. You would also agree with me that you have PT is equals MC change what? Temperature, and this is from electrical what? Power. All right. PM means what? Power, and TM is what? Time, and this one means what? Current. Now you also agree with me that power is equals what? The product of current and what? Voltage. All right. The product of current and voltage, which means that wherever I see my P, I put what? IV. So it becomes IVT equals what? MC change what? Temperature, equation 3. All right, take it like that, bit by bit. But you also agree with me that from Ohm's law, V is equals what? I arrow. V is equals what? I arrow. V connote what? The voltage, I connote current, and arrow stands for resistance. Okay, or resistor. Now the next one is wherever I see V, what will I do? I will have to put what? I arrow. In doing that, I'll now be having okay, I times what? Arrow. Okay, and that will give me MC change what? Temperature. Therefore, our final answer becomes I squared arrow equals what? MC changing temperature, equation 4. Equation 4. Now you have V equals what? I arrow. All right, I want to make I the subject formula. I want to make I the subject formula. I'll now be having arrow, arrow. So which means wherever I see I'll put what? V over arrow. Is that not correct? So if I have this, it means I'll now be having it to be, I think I'll have the same thing if I should do that. I think so. Okay, I have V squared over, all right, V over arrow, all squared times what? Arrow equals MC changing temperature. All right, so okay, you have V squared, arrow squared. So this arrow will go into this arrow, but you'll be left with what? One arrow here. So this becomes V squared over rho is equals what? MC change what? Temperature. Alright. So which means wherever I see I'll put what? V over rho. These two outsides are affecting both the V and the rho. So you have V squared, you have this. So this 2 is affecting this, that is rho squared. If I should remove one arrow, you have two arrows here, and I remove one arrow from these two arrows, I'll still be left with what? One arrow. So that is what you have it to be. Okay, that is for that. Let me also deduce something right now. Let me make, okay, I've made, let me make arrow the subject formula. I have that V is equals what? I arrow. Divide both sides by I. So arrow is equals what? V over I. So let us check if we get something reasonable. Okay, you are going to get the same thing, all right? So please take note of these formulas. IT is equals MC change in temperature, that is equation 1. PT is equals MC change in temperature, equation 2. Then P is equals I times V. This I represents what? Current, which is measured in ampere, and voltage is measured in what? V, like volts. It's measured in volts. So you have current times voltage times time, all right? And you have, please, this time you must always calculate in seconds, all right? If you have the options occurring as minutes, and you have the question, you have the time to be in minutes, you don't have to convert because the options are in minutes. But if the figure in the question is in minutes, all right, and you have the options to be seconds, you will have to convert from minutes to seconds by multiplying by 60. If t was given as 10 minutes, to convert to seconds, it becomes 10 times what? 60. That is for that. So we now have here voltage over whatever. So please, this is the last step for now. All right, let us start. Okay, please let me also say something, please, very important. The work done, all right, is equals P over V2 minus what? V1. V2 minus what? V1. There's the work done, and P is what? The pressure, which could be in atmosphere, in form of ATP, atmosphere. V2 is what? Final volume, and V1 is what? Initial volume. Okay, take note of that. It is very, very important. So let's start solving questions. Why am I sweating like this? Oh, excuse me. So let's play with some questions here. All right. You have a question that goes like this. I think I'll just dictate and you write. All right. If you don't have to write everything, just write out the parameters. They said an electric heater rated 220 volts. That is 220 volts. That tells us is what? V, which is what? Voltage. An electric heater rated 220 volts, then 1000 watts. Watts tells you is what? Power, right? Because power is measured in what? Watt. Is immersed in a bucket full of water. Calculate the mass of water of the temperature. Okay, calculate the mass of water if the temperature changes from 30 degrees Celsius to 100 degrees Celsius. So it means that temperature now becomes what? Q2 minus what? Okay, theta 2 minus what? Theta 1. And they said it changes from 30 to 100. That becomes 100 minus 30. And that will give me what? 70 degrees Celsius, alright? And the current flows for 300 seconds. So which means that time is what? 300 seconds. Now listen, from the question you can deduce the formula that you are to use. They give us voltage, they give us watts, and they say the current flows. So on that note, it means we are using IVT. It means we are using what? IVT. That is IVT equals MC change in what? Temperature. But from the question, current wasn't given, so we have to uh, look for the current first before we start solving. I give you that P is equals what? IV. P is equals what? IV. Now, to calculate for the current, it means we are going to make it the subject formula. All right. The voltage was given as 220. Okay, divide both sides by V. So I is equals, the power was given as what? 1,000. All right. The voltage was given as 200 and what? 20. This will go into this. All right. So let me use calculator so I can be quick. 100 divided by 22. I'll have currents to be 4.55 ampere approximately. So with this, it means that food is ready. All right. So we have to calculate the mass of the water. The mass of the water. So it becomes IVT. Okay. Let me go through the points. I have 4.55 times voltage, which was given as what? 220 times time, 300 seconds, equals, we are looking for the mass of what? Water. The mass of the water. We are looking for the mass of the water. So it becomes please, the specific capacity of water is usually 4,200 that is 200 joule per kilogram Kelvin, right? As I give you, that's kilojoule, that's kilo, that joule per kilogram per Kelvin. If I don't do it like this, I'll do it like this. They are both the same. Okay, then times. Now they told us that temperature changes from 30 to 100. That becomes 100 minus 30. That will give me what? 70. Then times what? Mass. Okay, so what do I have here? So 4.55 times 220 times 300, that would give me 300, then equals, let us do this. So 4,200 times 70, that will give me 294,000. Then mass, divide both sides by 294,000. 294,000. All right, so what will I have then? I'll have 300 divided by 294,000 equals, I did no error, 0. Oh, let me see, let me check. Okay, yes, so we have, let me do it again please. 4.55 times 220 times 300 equals, very correct. Then we have 4,200 times okay, that's times 70 equals 294,000. So 300 divided by 294,000, that will give me 1 point. Okay, which means that time is equals what? 1.0202. Okay, let me just make it 1.02. Okay, to two decimal places, 1.02 seconds. That is how it is. From a question, you can deduce the formula that you are to use. It is very, very important. Okay, so please, you were not given currents. What do? You look for the value of currents. In doing that, you have to use this. All right, you make I to from the number having P over what? V. Power is 1,000 and V is what? 220. Divide, substitute, and do whatever, you get your answer. Then I have what? This. I believe this one is understood, because I want to take the next question that I have here. So the next one, I believe we are following. All right, the next one is now they said please, you just write it out. A 0.250 kilogram of cup at 20 degrees Celsius is filled with 0.250 kilogram of boiling coffee. All right, that boiling coffee, let's make it water. Let's just assume to be water. The cup and the coffee came to thin equilibrium at 80 degrees Celsius. All right, so which means that T3 is what? 80 degrees Celsius. If no heat is lost, what is the specific heat capacity of the cup? What is the specific capacity of the cup? So our relationship here is between cup and what? Water. So it means that the mass of the cup, all right, times, all right, the specific capacity of the cup, then times the temperature change of the cup. And that means I'll now be having T3 minus what? T1. So the next one is what? Water, because we are relating with two entities here. So mass of water, specific capacity of water, then you now have T2 minus what? T3. All right. So from the question, they said a 0.250 kilogram. So this is the mass of the cup. So this is 0.250 times. Okay, let me bring out my parameters. So mass of cup is equals 0.250. That is the mass of cup. And the temperature is what? 20 degrees Celsius. Then the mass of water, is given as 0.250, the same thing, 0.250, that's kilogram. Then it came to a common equilibrium as this T3 equals what? 80 degrees Celsius. If no heat is lost, what is the specific capacity of the cup material? So we are looking for this very idiot. So it becomes T. Then T3 becomes 80 degree minus T1, which is this guy, 20, is equals, the mass of water was given as 0.250 times, then the specific heat capacity of water was given as, and it's constant, that is 4,200. Should I rub off this one? Yes, since I've written it out, so let me rub off this place. So then the temperature change now is T2 minus, okay, the same thing, 80 degrees Celsius minus what? 20. All right, so that is for that. So we are looking for this guy. All right, so we now have, let us go straight to the point. 80 minus 20 is what? 60. 80 minus 20 is 60. That becomes 60 times 0.250 equals 15. This would give me 15C. All right, so then equals, let's go into this. 80 minus 20, I'll get what? 60, right? So that becomes 0.250 times 4,200, then times 60. That will give me 63000. All right, so divide both sides by 63000. 63, is that no, you don't do that, please. You are dividing by both sides by 15. All right, 15. All right, so you say divided by, say, 63000 divided by 15, you have 4,200. So since is the specific capacity of the cup now, becomes C equals what? 4,200, all right, joule per kilogram per what? Kelvin. So this is what? The answer. This is the answer. You see, we are asked to calculate for this. The relationship was between cup and what? Water, which was mentioned as what? The boiling coffee. That is for that. So the next question. So I'll rub off. Okay, there's this. Jesus. we don't have much time on our side. So the next question, they said a 60 gram of water, which means, okay, a 60 gram of water at 90 degrees Celsius is poured into a calorimeter containing 20 gram of water. So the relationship between is water and what? Calorimeter. So it becomes the, oh God of Nazareth, what kind of marker is this? So it becomes the mass of water, specific capacity of water, and temperature of what? Water equals the mass of copper, specific capacity of copper, then temperature of what? Copper. So from the question, they said the mass of water is equals 60 gram. So we have to convert to what? Kilogram. In doing that, you say 60 divided by 1000, that'll give you 0.06 kilogram. That is the mass of water. Then the mass of copper was given as what? Okay, not the noise copper is calorimeter, please. Calorimeter. I thought it's copper. Let's be specific, okay? So mass of calorimeter. So it was given as what? 20 gram. So it becomes 20 gram is equals 20 divided by 1000. That'll give me what? 0.02 kilogram. Okay, so from this, food is ready. So mass of water now becomes 0.06 times specific capacity of water is 4200 constant. Then temperature change becomes that is 90 minus 30 degree, then equals you now have okay, they said what I'm calculating for, please. The temperature of the mixture will be, okay, so we are looking for what? T3. We are looking for T3. Yeah, I just read the question now. So T3 minus 90. 90 is what? From the question, 90 was given as what? T1. All right. Then T3 isn't given. All right. T3 isn't given. Then T2 was given as what? 30 degrees Celsius. So it wasn't, that is, we are looking for the final temperature. So equals the mass of calorimeter is 0.02, then times the specific capacity of calorimeter was, okay, it wasn't given here. Oh. Okay. So which means since water was not given, all right, so which means we are leaving it as C. It wasn't given, so it means that C is also here. So C will go into C. All right, so which means that we are not to touch the C, we are to cancel them out since it was not given this question right now. So then the next one is what? The temperature change. So it becomes T2. T2 is what? 30, right? So 30 minus what? T3. So I'll put this one in what? A bracket. So it becomes 0.06 times T3. I'll have 0.06 T3. Then minus 0.06 times 90. We have it to be what? 5.4 equals 0.02 times 30. 0.02 times 30 equals 0.6, then minus this times this, you have what? 0.02 T. Alright, so we have to collect like terms. In doing that, it becomes 0.06 T3, then plus 0.023 equals 0.6 plus is crossing 5.4. Alright, so let's take it. 0.06 plus 0.02 equals 0.08 T3 equals then This should be 6 if I'm not mistaken. 0.6 times 5.4 equals, okay, it's plus, sorry, 0.6 plus 5.4. Yeah, that will give me 6. So divide both sides by 0.08, 0.08. So it means that, oh God, I'm sweating. So from this place, that means that our T3 is equals 75 degrees Celsius, all right? So which means that our final temperature from the question is what? 0.5 degree Celsius, all right? So should I take one more question before I round it off? Should I take one more question? Okay, let me just take one more question then. In our subsequent class, we'll solve more questions on this topic. Okay, so there's a question here that says a gas is expanding against a constant pressure of 1 atm from 10 to 16 liters. What is the work done by the gas? What is the work done by the gas? I give you that work done is equals P over, that is open bracket V2 minus what? V1. Right, the work done wasn't given, so P was given as 1. They said that the gas changed from 10 to 16. That is 16 minus what? 10. That will give me W as what? Now what? 6. Alright, 6. But to calculate the final work done, what I just calculated is what? The liters. Alright, so now to not calculate the final work done, they said we should take 1 liter. We should take 1 liter to be what? 101. 10 what? 1. So which means that 1 liter would give what? 101.33 what? Joules. Then what will 6 liter give? We don't know. X what? Let's just make it X. So X becomes this times this. Alright, so 6 times 1 or 6 times 101.33 equals, have it to be 607.98 joules. 98 what? Joules. Okay, 98 joules. Okay, the final work done is this. All right, so since they said we should take 1 liter to be what? 101.33 what? Joules. Okay, that is for that. Should I take another one? Okay, let me just take this one as the last question for today. They said a waterfall 500 high, if the water retains 60% of the heat generated at the end of the fall, calculate the change in temperature due to the fall. You also have an electric heat of 60 watts is used, all right, to heat a metal block of mass 20 kg for 5 minutes. Calculates the specific heat capacity of metal block of if it rise to what? Whatever. Okay, from this question, okay, so we have to calculate change in what? Temperature. Change in temperature. And it said a waterfall 5-meter high, so which means that the height is what? 500 meters, and they gave us G to be what? 9.8 meter per second squared. Okay, they said specific heat capacity of water now is equals of 4,200, all right, 200 joule per kilogram per what? Kelvin. All right, so I think from what we have now, it means that we have to relate potential energy to what? The mass of water. So it becomes mgh You know mgh, m is mass, g is gravity, and h is what? Height. Then the mass of what? Water. Specific capacity of water, then temperature of what? Water. All right, temperature of water. So we are looking for the temperature of water. So it means that the mass we have to get out. Okay, so G is 9.8 times what? 500. So 9.8 times 500, I'll have, okay, you have 4,200. Okay, I think that is for that. Hope I'm not, okay, yeah. So that is what you have it to be, temperature. All right, what do you do next? Divide both sides by 4200, 4200. So this will go into this. So it means that 9.8 times 5 equals, divided by 42. I have, it means that the temperature now, I have it to be 1.1666. All right, temperature, I will approximate to 2 decimal places. So to one decimal place rather. I'll have 1.2 degree Celsius. So at this point, call it a day. In our subsequent class, I'll be solving more questions on this topic. Please subscribe to my YouTube channel so you can be notified whenever I upload a new content. Do have a wonderful night rest.